Today we will discuss involutory matrix of order 2. A square matrix A is said to be involutory if the square of the matrix equals to identity matrix. If this condition is satisfied, we can say the matrix is involutory matrix. On pre-multiplying by A inverse on both sides, we have A equals to A inverse. So we can say that a matrix is said to be involutory if it's equals to its inverse. Means if you have a matrix which is equals to its inverse, then matrix is said to be involutory matrix. And we know that the inverse of identity matrix is again an identity matrix. So identity matrix is an involutory matrix. Let us consider a real square matrix of order 2 with non-zero elements. That is, A is a matrix of order 2 whose elements are A, B, C, D. Then trace of this matrix A is given by sum of diagonal elements, that is A plus D, and determinant is given by product of diagonal elements minus product of non-diagonal elements, that is AD minus BC. This matrix will be involutory if it satisfies the condition A square equals to I. Now substitute the value of A. We have this matrix equation. On simplifying it, we get this matrix equation. Now, these two matrices are equal if and only if A square plus BC equals to 1, AB plus BD equals to 0, CA plus DC equals to 0, and CB plus D square equals to 1. So from here we have four equations. From equation 2, B is common, so we have A plus D equals to 0. Since B is not 0, so A plus D must be 0. Similarly, from equation 3, we have again A plus D equals to 0. And this is the trace of the matrix. Now adding 1 and 4, we have A square plus BC plus CB, or we can write it as BC plus D square equals to 1 plus 1, 2. On simplifying it, we have A square plus D square plus 2BC equals to 2. Now adding a term 2AD and subtracting it. So this A square plus D square plus 2AD, it becomes A plus D whole square. And taking minus 2 common from the last two terms, we have AD minus BC. But A plus D is 0. Substitute the value of A plus D. We have AD minus BC equals to minus 1. And AD minus BC is nothing but the determinant of the matrix A. So we can say that if any real matrix is given of order 2, then the matrix will be involutory if and only if its trace is 0 and its determinant is minus 1. For example, we have this matrix A whose elements are 3 minus 2, 4 minus 3. Now find out the trace. The trace is the sum of diagonal elements, which is 0, and determinant is minus 1. So we can say that this matrix is involutory matrix. Now summary of the lecture. A square matrix A is said to be involutory if A square equals to the identity matrix. Identity matrices are always involutory matrices. Any real square matrix of order 2 with non-zero elements will be involutory matrix if the trace is 0 and its determinant is minus 1. Thanks for watching the video. For more videos, please